Okay. We have started it yesterday, that means the first class. Actually, I'm reviewing the few things again, like what is a control system. Control system is actually the interconnection of component. As a result, we found a system. Having that system, we are getting the desired output, inserting the input in inserting the required input. Okay, and the definition is given here. The figure has been shown the open loop control system, which does not have any feedback, and it is the example of elevator. It is a common control system example. If we look at the figure, then you can see that when you press the button, here he is pressing 8, the lift will come to the 8 and it will go to the 8th floor. That means the you are giving the input 8 and the output, that means the lift, will go to the 8th floor. It will work according to your requirement. That is the example of a control system. And here is the response curve is given, like how it changes. If you look at here, that as the time increases, the elevator moves from the first floor to the 4th floor. At that time, it is at the 4th floor. Okay, what is the time actually here at that time? At that time, the lift at the or the elevator at the 4th floor. Here is a gap. This gap is known as the steady state error. Okay. So this is the response curve, elevator response curve. This is the elevator response curve. Okay, full curve is the elevator response curve. Okay. Here is the input command. You want that it comes to the or it goes to the 4th floor. Okay. So the output is not 100% accurate. There will be some error. That error known as the steady state error. Okay, some advantages are there. Control system like the power amplification, remote control, convenience of input form, compensation for disturbances. These are the advantages of control system. And it is the example of an open loop control system. Open loop control system does not have any feedback. That is the main difference between the open loop and the closed loop control system. Yes, see, an open loop control system utilizes an actuating device. It is actuating device to control the process directly without using feedback. So without having the feedback, the actuator will do the other job. Okay. And open loop system has some advantages and disadvantages. Like advantages like what? It is simple, inexpensive, and it has faster response. These are the advantages. And what are the disadvantages? High steady state error, not immune to the disturbance. Okay. These are the advantages and disadvantages of open loop control system. And here is the closed loop control system. A closed loop control system uses a measurement of the output and feedback of this signal to compare it with the desired input, reference or command. Like say, here the difference between the open loop and closed loop system lies in the feedback. The feedback has the sensor uses as a feedback. If we want to here see that one thing, that is plus the difference. Okay, here the difference is the important. Let's say you give 4, it will check Is it 4 or not? Let's say let's say that this is 1. When it is 1, then it will not stop. When it is 2, then it will not stop. Why it will not stop? Because the difference between the 4 and 1 is 3. 4 minus 1 is 3. Okay, 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. So when the elevator at the fourth floor, then 4 minus 4, 0. So when it will be 0, then it will stop. That means according to my input, it will work. Okay, here the system by which it senses that at what position it is, that is the sensor. Okay, that is the feedback. It is the difference between the open loop and closed loop system. Main difference is the feedback. And some closed loop system has some advantages and disadvantages, like it has less sensitive to the noise and disturbances, low steady state error, greater flexibility, often by simple gain adjustment and sometimes by redesigning the controller. These are the advantages, and disadvantages are there, like it is complexity. It has complex. The system is complex, and it is expensive. Okay, if you want to design or if you want to buy a closed loop system, then it will take some money, and it is slower response. Response is slow. Okay, these are the advantages and disadvantages of the closed loop system. Okay, and if you want to design a system, control system, then you need to remember the few things, like this is transient response, that means how fast it can go. Steady state error, this error, stability. Is it stable or not? Stability. So these three things are important parameter to design a control system. Okay. This is the positional control system. Okay, this is the positional control system. A position control system converts a position input command to a position output response. Okay, some applications are like antennas, robot arms, computer disk drives. These are the application of positional control system. Okay, that means position will be changed if according to your input. Here, see, that is the antenna. Here they are using a potentiometer, desired angle. Then the differential amplifier and power amplifier will power up the motor and another potentiometer. As a result, it will move. If these two moves, okay, motor will run, pot will be run, another pot, and it will move this one. It will move this one. If it moves, then the antenna will move. Here is a functional block diagram. See, that is not the block diagram. Block diagram is this one. Here, this port works as a sensor. See, angular input transducer, voltage proportional to input, summing junction, this one called the summing junction, and error or actuating signal, controller, planter process, angular output, then it will check voltage proportional to output. And here is the difference. Okay. That is the function block diagram of the positional control system. So if I ask you to write the functional block diagram of a position control system, then this will be your answer. Okay. Okay, another example is the boiler generator. Just look at here what things we are giving. See, this is the boiler. Here is the computer. In the computer, we are giving these things: temperature, pressure, oxygen, and generation. That means we are saying that the temperature of the system should be within this range, and what should be the pressure, what should be the oxygen level, and what is the generation we want from this system. Okay, watt, that means that is the watt. It could be megawatt or it could be kilowatt, but we are setting the threshold level. These are the level we are setting here. Okay, this level we have set. Then what do we see? The feed water has a valve, fuel has a valve, and air has a valve here in the boiler. So in the boiler, you have to maintain a certain temperature as well as the oxygen, certain oxygen level, as well as the pressure. Okay. See, the oxygen measurement. Here, the oxygen level of the boiler comes to the computer, as well as the temperature come here, pressure also comes here, and finally, when the turbine runs, then the turbine will run. When the turbine rotate, then it will generate then it will run the generator, and generator will produce the electricity. As a result, we will see the actual generation. So it is also come to the computer. So when the computer get the values, then it will compare the given values. Then if the values are exact, then it will run. But when the computer see that the level have been changed, then according to the level, this valve will be closed or open. Okay, if it see that anything mismatch, then it will close the valve. Instruction to close the valve will be go there. Okay, will go there. And see, according to this, the speed governor, that means speed will be monitored by the computer. Okay, so see, all things are computerized. Okay, this is the actually a system in the power plant, boiler generator power plant. Okay, that is the control system diagram of a power plant. So I think you have understood this. Okay, so you can control these things. The description is here, so I am not describe it again. So I think you will understand this if you read this. Okay, another example is the automobile. Okay, if you see that it is an example of a control system, closed loop control system. See, desired course of travel, that means it is our desired target, and that is actual course of level. And here the desired direction of travel, actual direction of travel. Okay, actually the driver will measure from the visually. Okay, he is observing. If here any dog or anything else, then he will stop or he will move around. Okay, that's it. So automobile system is another example of the closed loop control system. See, here are some examples are there. Just you can look at it. Okay, so if you want to design the control system, then you have to make sure that a few goals you have to set, right. Like the goal of control system control engineering design is to obtain the configuration, specification and the identification of the key parameters of a proposed system to meet the actual need. So what you required, you need to ensure that. Okay, here is the diagram of the control system design. First of all, you have to establish the control goals, what you are going to design. Okay, first of all, that is your control goals. Like shading indicates the topics that are emphasized in each chapter. Some chapters will have many shaded blocks. Okay, okay, that means the what is your goal? Identify the variables to be controlled. So you have to identify which variable you are going to control and write the specification according to the variable. Establish the system configuration and design the system. Obtain a model of the process. Describe a controller and select key parameters to be adjusted, which parameters you are going to adjust, and finally optimize the parameter. So if it does not work, then you have to go again here, establish the system configuration. Okay, if the all things are correct, then you can finalize the design. So first three, these three is the establishment of goals, variables to be controlled, and the specification. These are the first three. And the second two, these two are called the system definition and modeling. And last two is called the control system design, simulation, and analysis. Okay, actually this is the block diagram of the control system design at a glance. Okay, this is the control system design block diagram. So it was our first chapter. And we have two books, control system engineering 6th edition, Norman is nice, and the modern control system, Richard C. Dorff. I have this one also. Okay, now let's look at let's go to the second chapter, which is another chapter from the book. I'll show you this second chapter from the book because I do not have the PowerPoint. Okay. That is the chapter 2. We are studying it. We are going to study it from the book, chapter 2. First of all, see what we are going to study here from the chapter 2. The Laplace transformation, the transfer function, electrical network transfer function. Okay, these things we are going to study here. Okay, these are very important things for you. Modeling in the frequency domain. Chapter title of the chapter 2 is the modeling in the frequency domain, and we'll see the chapter 3 later. That is modeling in the time domain. Okay, chapter 2 is the last chapter. If we can complete this one, then you'll understand many things. Let's go to the chapter 2 here. It's still chapter 1. Oh, see one thing. Let me show you. You can also use this one, this block diagram also. Okay, the design process. The block diagram I have showed you earlier, that is from the book of the Dorf, C. Dorf, but you can use this block diagram also from the Norman S. Nice, from the book of Norman S. Nice. Okay. Okay, here just see a few things. Let me show you. See this one. This is called the impulse response. These are the waveforms. Okay, this kind of waveform is called the impulse. That is called the impulse waveform. And it has the function delta t. It is called it represents as delta t. That is the impulse. And this is a step function. This is a step. Ut is equal to 1 for t is greater than 0. When the t is greater than 0, it is 1. When the t is less than 0, it is 0. Okay. So it is the step function ut. And here is the ramp function. That is the ramp function. That is the ramp. Remember this. That is the ramp. That is the step. That is the impulse, and that is the parabola. And you know the sinusoid. You know the sinusoid. Ramp C T ut. The function represents as t of ut. It is the time. That means the function changes. The ut changes according to the time. And parabola half t square ut. Okay, half t square ut. It is the parabola. And it is a sinusoid, sine omega t. Sine omega t is the sinusoid. Transient response model is t-stator. Okay, so this kind of waves will recur throughout the control system. So you can put this wave as the input. Okay, remember this table. It is the table 1.1. Test waveforms used in the control system. So this kind of waveforms are used in the control system. Okay. So see again, this is the impulse, this is the step, this is the ramp, and this is the parabola. And there is a sinusoid, that is the sine omega t. Okay. They have used MATLABs, but we will use the octave. See, some problems are there. Aircraft attitude defined. Some examples are there. Let's move on to the chapter 2. Okay, that is the chapter 2, modeling in the frequency domain. Okay, modeling in the frequency domain, that is the chapter 2. So far we have seen that is our open loop control system. It might have multiple subsystem. Okay, here input is represents as the RT, output as CT. Input as RT, output as CT. Okay, here inside the system that there are some subsystems, like here 3 subsystems are there. Okay, block diagram, 3 block diagram. So our input is RT, output is CT. Remember this. Okay, now let's look at the Laplace transform. Okay, do you have any idea about the Laplace?
Yes, sir.
Okay, Laplace transform. Let's say this is the Fs, 0 to infinity, all right? 0 to infinity, that is the Laplace transform. This is the range. Ft e to the power minus st dt. Here S. Here S is what? S is actually sigma plus J of omega. That is the S. S is the sigma plus J of omega. Okay, that is actually S. What is this? That is J omega. That is sigma. That is negative sigma. That is negative J omega. So S is equal to sigma plus J omega. So obviously it is a complex term, complex. That is a complex variable. S is a complex variable because here see the J. Here see the J. Negative J, positive J. That means the imaginary axis. That is the imaginary axis. That is the real axis. Okay. So that is the definition of Laplace transform. Okay, now see the another table. That is the Laplace transformation table. Laplace transform table. Here the Laplace transform table. See delta t is equal to 1, ut is equal to 1 by s, tut 1 by s square. See here is the function ft, but when you do it the Laplace transform, then the function will change. Okay, the Laplace transform of this function is this one. Okay, so you have to remember this table. Okay, remember all parameters here, just memorize it. Here they showed a example like find the Laplace transform ft is equal to a e to the power minus ct ut. Now see, since the time function does not contain any impulse function, that is the delta t, we can replace the lower limit with the 0. Hence fs 0 to infinity ft minus est dt. Instead of ft, we can write this one, we can write this one. Now do the integration, then you will see this. Okay, finally a by s plus a. Okay, it comes from the integration. Okay, and some inverse Laplace transforms are also there. Partial fraction is important here. Partial fraction. Just look at the example. Now see 2.3. Given the following differential equation, see this is your differential equation. Solve for yt if all initial conditions are 0. If the all initial conditions are 0, use the Laplace transform. D square. See here, this is our equation. Now we have to do it the Laplace. See, instead of d dt square, d square dt square, we can write the s square, because d of dt is actually the s. D of dt is equal to s. So if it is a square, then it will be the s square. And y, the small y, in the Laplace, it will be the large y. Okay, and the 12 is as it is. D dt, instead of d dt, we can write the s. Instead of y, we can write the ys. 32y, 32ys, 32 ut, 30. So the Laplace transform of equation 2.14 is this one. That is the Laplace transform of this equation. So instead of ut, we can write the 1 by s. Okay, so that is the Laplace transform. Now, if you solve this for the ys, then what you will see? Just the math. Okay, this is a simple math. Like what they did, ys is equal to, sorry, if you take the common, then s squared plus 12s plus 32 is equal to 32 by s. Okay, so ys would be like this. So it will go down 32 here, s into s square plus 12s plus 32. And finally, what you can do, you can do the middle term factor. 32 is here. So middle term factor, if you do this, 4 into 8, s plus 4 plus s plus 8. S into s plus 4 into s plus 8. Do you know how it comes? If you do the middle term factor, 12s plus 32, you can write this like s square plus 4s plus 8s plus 32. That means that you just multiply 4 and 8. Now take the common, s plus 4 plus take the 4 common, sorry 8 common, s plus 4. So it would be s plus 4 and s plus 8. So they did this. Now that is your equation. Now you can break it like this. Okay, if you want to partial differential, partial derivation, if you do this, s k1 by s, k2 by s plus 4 plus k3 by s plus 8. So for the k1, if you want to find the k1, then do one thing, put s the 0, then you will get the result, that is the 1. For the k2, here put s is equal to 4, s is equal to minus 4. Okay, then you will get the k2 minus 2. For the k3, put the s is equal to minus 8. Okay, so finally you will get this equation. That will be your equation. So that is the example 2.3. And finally, you can write this equation yt 1 by s, that means the 1 minus 2, 1 by s plus 4 means 2 e to the minus 40 plus 1 by s plus 8 means e to the minus 80 ut. Here I have, they have write those things according to the this one. See, 1 by s plus a minus is equal to e minus 80 ut. That is the ft. Okay, time domain. That is the frequency domain. That is the time domain. Okay. Tut means 1 by s square. Ut means 1 by s. Delta t means 1. Okay, remember these things. Similarly, some few more examples are there, I think. Another example is has been given, and here are another example. Fs 10 by, okay, this you can check it. Okay, now our important parameter is the transfer function. What is the transfer function? We need to know the definition of transfer function. Okay guys, I will give you another link, because I'm giving another link because time will be end soon. Okay, so I have to give you another link. Okay, so transfer function. Okay, what is the transfer function? Transfer function is the, okay, let me do one thing. Just I have disabled the, okay. See here at the definition, transfer function is actually the output by input. Okay, that is the output by input. That means if we look at the figure, block diagram, see the block diagram. That is your input RS in the frequency domain, that is the output in the time domain. So here is the transfer function GS. So the transfer function GS would be output CS divided by input RS. So that is the transfer function. Okay, that is your transfer function. Output by input. Okay, that is the transfer function GS. So they have said that CS. So here we can write the CS. CS is RS into GS. If you look at this one. Okay, now say find the transfer function represented by this one. Let's say this is the equation they have given to you. Now you have to find out the transfer function from this equation. Okay. Now how to find out the transfer function? So now that taking the Laplace transform both sides. So just take the Laplace transform. Okay. If you take the Laplace transform, then what will happen? See, instead of let's say this. So the at first, so what is the Laplace transform? S CS. Okay, S CS first one plus 2CS is equal to RS. Okay, now take the CS common. Take the CS common, then what you'll see is plus 2 is equal to RS. RS. Now, just if you write the CS by RS, CS by RS is equal to 1 by S plus 2, or is equal to GS is equal to 1 by S plus 2. So that is your Laplace transform. 1 by S plus 2 is your Laplace transform. See, sorry, so this is the transfer function. So the transfer function GS is equal to 1 by S plus 2. That is your answer. See, very simple math. Just take the Laplace transform and find the GS. Okay, that is the way to find out the transfer function. And see, system response from the transfer function. Another example is given here. Use the result of example 2.4. That means the result of example 2.4. Here it is the result of example 2.4. To find the response CT to an input, RT is equal to UT. If the RT is equal to UT, a unit step, assuming zero initial condition. Okay, to solve the problem, we use the equation 2.54. So we use the 2.54. What is the equation of 2.5? This one. C is equal to RS into GS. C is equal to RS into GS. So here, what would be the CS? C is equal to RS into GS. So it is the GS. So just multiply it. RS into 1 by S plus 2. So C is equal to RS into 1 RS into GS. So instead of RS, what you will see, they have said that RT is equal to UT. That means the unit step. RT is equal to UT. That is the unit step. Okay. So that is the unit step. CS is equal to RS into GS. So 1 by S into S plus 2. So the partial fraction, if we do the partial fraction, they'll get, then we'll get this one. So let me show you how we can get the partial fraction. So you can write the A by S plus A B by S plus 2. Okay, so now we can do the calculation here. Now let's say now S, if you put the S equal to 0, then what you will get, uh, if you put the S equal to 0, then you will get this one, like uh,
B equal to
this one. Okay, if you put S equal to 0, then you will get the this one, and if you put the S equal to -2, then you will get the this one. Here 0, here 0. Okay, that means this one will be 0, so the equation will be like this. That means the CS. Okay, CS would be like this. uh, B by, if let's say if you put the 0, B by 2. Okay, okay, so B by 2, that means the B will be half, because let me write it again very clearly. Let's say uh, the equation, let me first write the equation. 1 by S into S plus 2, right? And the equation is A by S plus B by S plus 2. Okay, now when S is equal to 0, when the S is equal to 0, then this one will be 0, right? This one will be 0, and this one will be 0. Here instead of B, we can write that 2. So we can write 0 is equal to B by 2. It is okay or not? I don't think it is okay. 1 by S, yes. 1 by S plus something wrong here. Not like this. Let me check. Just go to the partial. Derivative. We have to check this one. See the equation here. Like this, right? That is the equation. multiply okay. So here's okay. I just missed a thing. Just a minute. Okay, here the thing
স্যার
is
কি কি আছে স্যার?
না না ঠিক একটু একটু একটা জিনিস আমি খেয়াল করি নাই মাল্টিপ্লাই করতে হবে তো let's say you have 1 by s into s plus 2 is equal to a by s plus b by s plus 2. Okay, now multiply it by this one, multiplied by this, and then it is 1. Then here a into s plus 2 plus b into s. Okay, just if you multiply both side by this one, okay, by this one, then you will get this. Now put s is equal to 0. Now if you put s equal to 0, then it would be a into 2. This is 0, so a would be half. Okay, if you put s is equal to now minus 2, if you put s is equal to minus 2, then here see 1 is equal to minus 2b, minus 2b, so b would be minus half. Say just you have to multiply it. Okay, you have to multiply it. So it is a is equal to half, b is equal to minus half. So just put here a is equal to half, b equal to minus half. Here comes the minus. Okay. Now if you change it to take the inverse Laplace transform, that means the ILT, inverse Laplace transform, that means the ILT, then instead of CS you can write the CT, and half is there, 1 by s, half 1 by s, and that is 1 by s means what? Just check the table. Okay, just you have to check the table, then you will see it is actually delta t impulse. Then minus half, and instead of 1 by s plus 2 you can write the, since it is plus 2, so you can write, it will be minus 2 here. So how it comes? It comes from the table. Okay, just go to the table, then you will see. The table is important here, very much important table. This table. See, 1 by s means ut. 1 by s means ut. 1 by s plus a means e to the power minus 80 ut. Okay. So that is the thing. So that is the Laplace transform problems. This kind of problems here, this is the transfer function 2.4, 2.5. Okay, similarly, they have given some few more examples. Okay, like assessment 2.4, 2.5. Okay. So today I'll stop here. Okay. So up to the transfer function, Laplace transform, and how to inverse Laplace transform. See, here is another example. See, that is another one. Okay. You can also break this one. If you break this one, then you can get this, get like this. Or if you break this one, then you can get like this. You'll get the solution here, complete solution. If you go there, then you'll get the complete solution here, just according here. No, I do not want to. I do not want to go there. Okay, so you will find the solution of the skill assessment exercise in the website. Okay, just check the website. Check the website, then you will be able to see.